Hey guys, I just wanted to put a video together highlighting some of the key changes coming to TweenGMS 2, tweening engine that I've been working on for GameMaker Studio 2. I just wanted this to be a kind of a quick, I don't know how long it'll take, but a really casual video just highlighting some of the key things that I have listed here. I've left my notes in here clearly because I'm just going to work my way through them and try to remember what I'm talking about. I've got a cat meowing at my feet. I got stuff around me, so there could be background noise and stuff. I might just try to roll with it and hope that RTX voice cuts out stuff in the background. And if it doesn't, whatever. All right, so what I have set up here is a basic little test project with the red square guy. That's all it is. And I have some code. So I'm using GMLive for this example, which is made by Yellow Afterlife in the GameMaker community. So this is going to allow me to do some live updating without having to recompile the examples here, which is really nice. So I'll leave a link to his asset in the video description if you guys want to check that out. Other than that, in the step event of this object, I also have, when I press the right mouse button, it'll reset the square to its original position. Before I start, for anyone, this beta stuff here, you can try the beta now if you want. It's available on itch.io. I'll leave a link to the current TweenGMS 2 beta for you guys to check out if you would like to do so. But maybe don't use it for live production. It might still have some bugs to be worked out, especially with the new garbage collector and stuff like that. But it seems pretty reliable at the moment, but just be a little careful before using it for live projects if you have serious things going on there. Other of that for now, yeah, also GameMaker 2.3.2 is required. So if you're on older versions of GameMaker, I'm sorry, but the newest TweenGMS will require the latest versions of GameMaker. All right, so now in this example, when I press the left mouse button, I just have a little effect to show where I've clicked. So that's all that this code is here. And now I'm going to work my way through all these to show some of the new key things coming to TweenGMS. And I'm hoping that you guys appreciate some of them and you guys can give me feedback and see which ones you like or what I could add and all that. But anyhow, this is going to be kind of a part one of 2 videos, I'm hoping. This will be some of the key new features, and then in a second one, I might touch on a more advanced topic for off-rail tweens, which I'd like to kind of more dedicate to that. But for this, I just want to highlight some of the key things. And with that said, let me just get started here. All right, so the first, I'm just going to unhighlight this guy here. And this is a pretty default tween that you guys, if you're already familiar with TweenGMS, this should look very familiar to you. This is nothing different, and this is still compatible with the existing version of TweenGMS. So your old code should largely still work. All right, so we're just tweening from, just with a linear ease here, from using the X variable, we're tweening from the current X position to the mouse X position. So when I click, he goes to the X mouse position. All right, so I'm going to comment him out, and I'm going to go to this next line. So with this new version, the TweenGMS 2 and TweenGMS from functions, so TweenGMS 2 and TweenGMS from are now obsolete because they have now been replaced with this little guy and this guy, the greater than and less than symbol. So now, instead of using TweenFire2, we can actually add this symbol to the end of a property string, and then we can just set just the destination value. So if I save this example and now click, it will do the exact same thing as above, and I just use this symbol to tell it to go to the mouse X position. Likewise, we have the from symbol. So now it's going to go, this is going to have the X value start from the current mouse position when I click, and the destination will be the current value of X. So I'm going to reset the example, and when I click, we see the square starting from the mouse X position going to the current value of X. All right, well, that's cool. But now I want to show that unlike before in previous versions where you had to use TweenFire2 or TweenFire_from, you can now mix the two if you want. So now we have the X variable being tweened to the mouse X position, and the image scale will be tweened from the value 2 to its current position. So I'm going to save this example, I'm going to run it, and now we see the image scale starting at 2 and working its way down to what I think is probably 1. And the mouse is going, the X position is going from its current position to X. We've mixed both to and from values, so which is really convenient. And the next example I have called the triple mix. Amazing, right? All right. So what this is showing is that I'm now going to tween the X value and explicitly set the start and destination values, like the first example. But I'm also going to use the to symbol and the from symbol. So we got all three versions here being used, and we can mix them all together at the same time, and thus producing that. So just showing that you can mix these things and put them all in a single tween rather than splitting them up or whatever. So you can just do that all from a single line of code now, which is cool. And with that in mind, there's also now this. This is the same as the very first example I did here, where you just move to the mouse X position. But just for some consistency and as an option, you can use this semicolon, which will do the exact same thing as up here, but it's just so that every different version has a symbol if you choose to use it for visual clarity. You don't have to use this. If you want to use no symbol, you don't have to. If you want to use a semicolon for clarity, especially when we discuss the off-rail tweens, it might help for clarity when reading code. But I'll just show you that this is going to just do the same thing as the first example. So that semicolon, totally optional, don't got to use it, but it's there just for some kind of consistency, readability, if it helps you. All right. Some of you guys might appreciate this. It's not a huge deal, but kind of is. The self keyword is now supported, so you can use self instead of ID if you like. This has more implications if you're using struct targets, which is a new thing, which I want to discuss in the next video. But yeah, so you can now put self as the target and it won't break things anymore. So that's cool. I think somebody probably appreciates that out there. All right, so now I'm going to try to catch up with my notes. So now we're going to discuss ease strings. Yeah, so before we've had two, so in this example above right here, put explicit like ease linear, ease in out, like function call IDs. But now what we can do is optionally, try to fix this guy here. We can use these e strings where there's you just put a string in with the right name instead of the function ID. So I'm just going to save this example and play this guy here and just show that that is working as before, but now I've just used the optional string method. But this is where it becomes more useful. So as an example, I'll first type in out sign. So I'm going to change this to the sign type. And now we have a sign easing algorithm used. But this is where we can start getting into more of the shorthand ways of using this, which may make it cleaner for some of you to use. So first off, I'm going to change the in out to just IO for in out. And that will work just the same. You can use I and O for a shorthand version of those. And because sign is actually kind of the default in a way for these e strings, you can actually just shorten it even to IO and it will still be in out sign. So if you really just want a really short way to write it out, you can just put IO and it will use the sign in out. If I do I, it'll just do in. And if I just do O, it'll do the out version of the algorithm, which is really cool. I also want to show you, but if you wanted to do like, let's say IO quad, let's do one more dramatic, IO elastic. I got elastic in there. But I wanted to show you that the case for these letters don't matter. So I could do I could do all caps in out quad, for example. It will be just the same as like in out quad, whatever case, it doesn't matter. So you can use whatever preference you want for the casing type, as well as it also doesn't care about underscores. So if you want to use underscores, those will work too. No problem. So pick your coding convention that you like. Case doesn't matter, underscores don't matter. Good stuff. Last thing, linear also, there's one more shorthand for just a default linear tween. An empty string will use linear as well. So if you just want a linear string, so basically just your basic movement here with, yeah. So that's the thing too. Okay, so let's move on. There's more, that again might be more useful when we talk about the off-rail tweens in the next video. Granted that I get to it. And then, so next, similar to the E strings, we have the mode strings. So it's like kind of like the easing types, except that for the modes, for the mode parameter in the tweens. Before you had to do like tween mode and then like pick one of the types, so like once, loop, bounce. You know, there was these different kinds, patrol. Or if you memorize them, you can remember that like 0 referenced the once, and 1 represented the bounce type, or 2 was patrol. So if you remembered that, you could use just straight up like numbers like 0, 1, 2, which I was doing in the examples like up here. But sometimes it's not clear. It's like, especially when I'm still using it, like is repeat 3 or is the loop play mode 3 or 4? And I still get confused sometimes, and I don't know. Usually it's fine for like 0 and 1 and 2. But anyway, another example I think we can do now is we can use the ease string types. So I could instead type, I could do once, and just to show that this works. That now works as the mode type for once, and I can do bounce, and this will bounce it. Perfect. And I can do patrol, and I will do the patrol easing type. Cool. And also the same as loop. I guess I'll just show you guys. So loop, maybe we'll start looping it and repeat. Actually, I'll do that. So now we'll repeat it. All right, so it's just another way to do it. And again, there's an extended shorthand version. You could do just for, let's say, patrol. You can put just the P if you want. Let me reset this. So P will do patrol. Once, or bounce will be like B. I just want to have the bounce mode. So you can just use the first letter from the mode as well if you really, really want to, but you don't have to. Again, casing doesn't matter. Do whatever you want for the case. It doesn't care. So choose your convention. All right, so that is neat. Let's carry on. Relative start destination values. All right, so let's unlock this one. So this looks pretty standard. We are tweening with the default in-out sign value here, the X property, to 100. But let's watch what happens. So this should go to 100, which would be about here, right, in the room on 100 X value. But let's play the tween and watch what happens. Huh, it moved to the right. Why? When we pass so this is a destination value. This is true for both start and destination values. So since this is a destination value, when I pass this as an array in these square brackets, it tells TweenGMS to pass a relative position. So instead of going to 100, it's going to go to X plus 100. So, and if I change this to negative 100, it'll actually move it 100 pixels to the left, back towards 0 there. So that's pretty cool. Yeah, I felt there was some more that I wanted to talk about this, but maybe that's it for now. So these are just some really cool things. Oh, I'll show like, let's do image scale, for example. So I could do 1.2. So I could image scale to 1.2. Let's reset the example and I'll scale it up. So every time I tween it now, it's going to scale 1.2 times the current value, which is just really cool. You can just have it scaled to tween to a relative value rather than an explicit value directly. And hopefully that's clear. Where if I just did like this, for example, now it's going to go to 1.2 and it's going to keep trying to go to 1.2. But again, if I put it in this guy, reset it, it's going to keep going to a relative value. So anyhow, I think that's pretty cool. There's really cool uses for that. Hopefully that might show up again later here. All right, so there's also these things called start and destination strings. They're limited to some degree right now. I haven't made them super incredible. You can't like do advanced stuff with them, but you can do some pretty cool things once you know the limitations. So anyways, I will show how this works. So I think I left this example broken, so please ignore me as I just fix this for a second. So, all right. So again, we have a pretty standard tween. It's going to play once. The X value is going to move to X plus 100. So, but what's going on here? Now the destination's a string. Well, how is this going to work? So let's reset the example and it will, it goes to x plus 100. So this is actually doing the same thing as I did before, but now we're using a string. But why would we want that? That's interesting. So something we can do here, I'm going to uncomment this value. So I'm going to add this variable to this object called value. And I'm actually going to change this to plus value. And let's watch what happens when I play it. So now it's adding value. So it's doing x plus value, which this is a negative value. So it's going to move it left, right? So we can actually, with the string, we can add in these values. Yeah, there was more I wanted to say here. So there's some, you might be wondering, why couldn't we just do this? Well, you can't. So we can do that. But, and again, you can, I have an example here I was going to show where you can explicitly do like global.value. You could do that so you can access global values. And there's some more advanced uses here. I think I'll leave it for the next video maybe. But I just want to show this is here. And yeah, I'll touch that I think in the second video, kind of the more advanced use case here. So, but I want to show why you may want to use these strings. There's a very good reason for it. So I'm going to comment that out. I'm going to go to this next line. So where the start and destination strings are helpful is when you have delays. So I have a tween here, and it has a 1 second delay before it starts. So I'm just going to, I'll comment these guys out so they're not there. So I'm going to reset the example, and this should move to the current mouse position after a 1 second delay. Sure enough, that happens. That's cool. So, but I'm going to change this now to just straight like that. That will do the same thing. But watch what happens when I click and then move the mouse. The object goes to where I had clicked and not the live position of the mouse. So notice the difference now when I put this into the string version. I'm going to reset the example, and I click and I move the mouse. It goes to whatever was the last position the mouse is in when the tween actually begins. So when the delay finishes, it then calculates the position of mouse X. So this is just a convenient way if you want to use the starting position or destination to be updated when the tween finishes the delay. So that's where these strings can be very helpful, calculating things on the fly rather than trying to update them manually another way. So again, I may touch on more advanced use cases in the next video. I just want you guys to know that this kind of thing is there. And again, I could do like x plus 100. So I could have it like click there, and then it should move 100. I don't know what just happened there. Did I save it? Yeah, so now it's x plus 100. So you can do that kind of thing. All right, so cool. Next, it's kind of related to the previous example, but there's this at symbol shorthand example, which we can use for these start and destination strings. So here I have at plus 90 for the destination of image angle. So I'm just going to play this example and show what that will do. Okay, it rotated it 90 degrees from its current position. So this at symbol is the same as angle. It's just going to take whatever the variable property string is and place it in there. So it's just a convenient way to keep things clean and short if you have long variable names. I could change this to X, for example, and it would then move it 90 pixels to the right. So it's just going to now be the same as writing X plus that. So it's just kind of a placeholder to fill in that for convenience. And I should also show that you can, with these, you can also multiply. So if I did at 2.2, maybe it won't work. Maybe I broke it. Maybe I'm lying. I don't know. I'll have to check my example. Uh-oh, something's breaking, guys. Anyways, I'll get back to that. I probably broke something. Maybe I need to fix a bug. Anyhow, on to the next example. On a lighter note, oh yeah, some light things in case I'm hurting anybody's head. It was already possible to do, so let me do this guy here. Let me just do like 250. So if I play a tween, no, I think I broke the example. I'm just gonna do a quick edit, cut, and fix things. Be right back. And I'm back. No, I didn't break anything. I was just being kind of dumb. I was trying to multiply 0 by a value, and we'll carry on. All right. So I wanted to show that. So yeah, in the previous versions of GameMaker, you could already, TweenGMS, you could already do this. You could use the all keyword for functions like TweenStop, TweenPause, TweenResume. Things like that. You could use this all keyword to affect all tweens. With the new version of TweenGMS coming, you can now use the keyword self and other. So if you just want to like pause all the tweens for a specific object, or like for the self, you can just do that. I'm actually doing that in this example up here. When I right click, I'm actually using TweenStop self. So whatever tween's going on right now, I can right click and it will stop it. I don't have to know the returned ID from the tween call. I just call on self and it will automatically check through all the tweens to see which one belongs to this current calling object, and it will affect that one. Yeah, so you can now use the self keyword as well as other. So say you had a collision with another object, you can say TweenStop other and it will stop the tweens for the object you collided with. Stuff like that. That's pretty cool. Less need to have to restore ID values and stuff like that. All right, next we are going to just try to comment these guys out. We have continue rests and counts. So what was I thinking here? All right, let's just uncomment stuff here. What does this guy do? He patrols between here and here. Cool. Right, so we can now add rests to, sorry guys if you're hearing my dog in the background whining. RTX voice should be cutting him out. He's fine. He's all right. I'm gonna comment this guy out. We can now add rest values to tweens that have continue modes, so like bounce, patrol, loop, repeat. So I'm gonna comment this out, and I'm gonna do tween set rest to 1. I'm gonna give a rest value of 1. I'm gonna place again and watch what happens. So this tween now rests for 1 second every time it continues. So it's gonna, yeah. So we get a nice little pause, which is pretty cool. Now, I'm going to comment out this guy here, and I'm going to pass it as array with 0 as the first parameter and 1. So if we pass, this is, sorry, I'm stumbling over my words. When we pass an array with 2 values to the rest setting, 0 is going to be the rest value at the start position, and 1 is going to be in this case, the rest value at the destination. So I'm going to save this and play it again. We'll see it pause for a second and go back and immediately start again. So now we have 1 second rest at the destination value and we have no rest value at the start. So this can allow you to create some cool, neat effects and stuff. So, and I could easily change this to like 0.5 and now it'll be 1 second and half a second rest, or 2 or 5 or whatever, right? So that's neat. We can also set the continue count. So before with patrol, it would just forever go, but now I can set a explicit amount of times that it will continue. So now when I play this, it's going to go from here and continue once and continue twice, and then it's done. Again, I can set it like 4 times, and we go 1, 2, 3, and 4, and we're done. Yeah, so that will work for the patrol mode, loop, and repeat. So just a cool thing to add in there. And also wanted to show that the tween set functions now support multi-value setting. So we can actually now affect, I'm going to put the tween here as the first parameter, and then I can set rest to 0.5 and the continue count to 2, all from 1 call. And it will, yeah, so both of those values are now applied in 1 call. Just a nice, clean way to do things rather than having to have multiple lines to that. All right. Oh, did I show lazy tween IDs? I did not. Thank you, past self, for reminding me. Okay, so I'm going to show you guys the new lazy. I'm going to call them lazy Tween IDs. So if you don't want to store the unique Tween ID returned from TweenFire or Tween Create or so forth, I'm just going to get rid of that. And let's unlock this example. And I'm just going to put 0. So if you put 0 into the Tween ID, it is going to reference the last created tween. So in this case, this is the last tween that's created. Do be careful with this feature. Only use it if you really, really know which tween is the last one created. I don't exactly encourage using it with the tween create function. But in this example, it's really clear that this is made, and then we're going to do this. So 0 will actually reference the last tween made, so we don't actually have to restore. So it will work just the same as before. So you can use 0 as a lazy way to reference the last created tween. Pretty cool. All right. Duration. I think this video is going longer than I expected. This is how long am I? Oh, wow. Okay. Let's keep going. If you guys are still with me. Cool. All right. Duration and ease swapping. So let's just see what this does. I'm going to play it. I'm going to reset it. Cool. All right. So I'll explain what's going on here. We have 2 different ease types being played. So I'm using a patrol mode. So this is going to be patrolling between these 2 locations for Y. But what I've done here is, if you pass the ease algorithm types as an array, again, kind of like before with this rest mode, this algorithm is going to be used played forward, and this is the sign algorithm is going to be used playing backward. So we see the bounce coming out, playing down. I'll reset it again, playing down, and then we're going to have the in-out sign algorithm going up. And then what I've also done here is for the duration, I've also passed as an array. So we're going to use a duration of 1 for the animation coming down, and a duration of 2 coming back. So as you guys can guess, this just allows for more flexibility and control with some cool animation effects without having to do callbacks and all that and trying to switch things up. It just allows you to, with one TweenFire call, have just these more cool effects. And then I could also add, oh yeah, I have it here. Look at that. So if I uncomment this guy, I now have like a rest. There's a rest effect in there. And then I could also do like pass as an array or something. So I could have like no rest on one direction and only on the one. So there's a rest there and no rest there. So again, tons of options. Pretty cool. If you're getting confused, guys, by this stuff, I'm sorry. Let's keep going. Property modifiers. All right. So what do I have here? Sure. I have TP shake here. I'm gonna not show that first. I'm gonna do TP snap. I'm gonna do 50. So this is gonna move the square here from about 100 pixels here to the room width minus 100 here. So he should move left to right. I'm gonna play it. But you'll notice something. I'll make it a bit more pronounced. If I play it now, we are snapping it to 100 pixels. So we're getting kind of this gritty, snapped animation. If I make it really pronounced, it should become really obvious. So if you wanted to like lock things to a grid, you could do that using this function called TP snap. And so this is the variable property. We have X here. So, but we use this function, we pass the variable here to the first argument, and then this value is setting the snap value or the grid value, whatever you want to call it. And yeah, it's just kind of a cool effect. We got other ones that I've built in. We have a TP shake. I'm going to turn that down. So this is, again, I'll make this a bit more pronounced. I think you guys can see that. So now it's shaking the value at a factor of 50. And then I'm actually going to add in here as well. I'll do Y, but I'm not actually going to change it. So I'm just going to use Y and Y. Like I'm not actually going to tween it to a different value. I'm just going to save this, but now I have the Y just shaking as well. So even if I didn't want the Y to go anywhere, it's staying technically at the same position, but it's still being affected by the shake. So there you go. There's some effects and stuff with these TP functions. There's other ones. There's TP functions for data structures. So there's arrays, there's lists, grids, maps. You can floor values, you can round values, you can seal values. So anyway, just some examples there. I'll just leave it with shake for now. So I will show you. All right. The next one here, Tween Path, which is in the previous versions of TweenGMS, there was an explicit function for tweening paths called Tween Path. That is now gone. If you still want a function like that, you can use Tween Easy Path now instead, which I actually have down here as an example, which I'll show you. So Tween Easy Path is now a thing if you just want that kind of old-fashioned use of tweening paths and TweenGMS. But here's the new official way to do it. Again, it's like above with these TP functions. So we have, by the way, TP stands for tween property, in case you want to know what that means. So we have these tween property functions, TP path. And this first parameter is the path you want to tween. So I have path cool here, which I've made. It's not amazing, but it'll work. So we pass the function ID, sorry, the path ID to the first argument, and then we set whether or not we want the path to be true, absolute or not. Kind of like the standard path start functions, like do you want the path to be absolute or not? In this case, I'm going to have it as absolute, so true. And then for the start and destination, I'm just going to put a 0 and 1. I want to start at the beginning of the path and finish at the end of the path. And I'm going to delete that for now. You didn't see that, guys. So let's just play what this looks like. Hey, so cool. I'm playing the path. But like, why did I change this from the original version of TweenGMS and just having an explicit call? Well, because of the thing I just deleted. Before you couldn't, let's do 0. You couldn't mix in other property types with that. You had to just do just the path tweening, and that's all you could do. So now you can actually mix path tweening with another property, and it's all associated with one single tween. So now if I play this, now we got the tween going with the path and the image scale. Cool. So I want to show what happens if I don't do to 0 to 1. If I do 0.05, it's only going to go halfway to the value of the function of the path. If I do 7, no, that's going to break things. That's not good. Here, so now it's only going to use like a portion of the path rather than the whole thing. So that's what happens if you change the start and destination values. So, which is just kind of cool that now we can tween paths with other more advanced tweens, bringing it all together with a single function call. No need to have separate calls. But again, I wanted to show you guys that if you still want that kind of easy, I just want to tween a path, I don't want to think about it, there's now a tween easy path function, and you can use that as well. So pretty cool. What else do I got here? Almost done. Normalized durations. Let's see here. What is it going to do? Okay. So up until now, you've had to explicitly set so if I set the duration of this tween, it's using delta tweening. So I want, my dog is really barking. Sorry guys, if you're hearing that. All right. So in this example, I'm going to have this object tween with a valid duration of 1. But if I put this into brackets, the duration value, it's now going to use this normalized duration. I technically don't know the best term for this, but I'm calling it normalized for now because it seems the closest thing that I can yeah, anyway, if there's a better phrase for it, you guys can let me know. So now, instead of having a duration of 100 seconds, it's going to move it's going to have a change of 100 over 1 second. So so on average, the X value is going to move 100 pixels per second. So if I restart this now, he is now on average moving 100 pixels per second. If I change it to 1000, he'll move 1000 pixels per second. So this is kind of nice for, I'll just show you guys. Why would you want to use this? Well, if you don't know what the duration of what you may want to tween something from a start to a finish, and you don't know how long the distance is going to be or how much time you actually want. But you might want the same speed to happen, but you just don't know. Anyway, I'll show an example here. I will highlight this guy out. Sorry if I'm explaining this poorly. All right. So I'm going to play this example. This X is going to move from his current position to my mouse position. So I'm going to click. So what's happening is he is moving on average 1,000, I guess, pixels kind of at this point per second. I could change this again to 500. And now even if I don't even know what the distance will be, TweenGMS is going to work out a way to keep a consistent speed. Because if I just did, let's say 0.25 seconds here. Okay, let's try this. So here, it's going to be the same no matter what. So if I do it really close, it's going to be like this, and if I go here, it's like this. It's not a consistent speed. All it cares about is time. It's my dog. Hey, buddy. Hey, okay, go lay down. Go lay down. Go lay down. All right, you got tired of whining. It's okay. I'll get you in a bit. Go lay down. Okay, so, but if we do, again, this, it's going to work out what the average is and keep kind of a more consistent speed rather than you having to calculate that manually and use a kind of a callback in between starts and all that stuff. Some of you guys might find that really, really useful, especially if you use the destination strings and you use a delay with it and you don't know, because you could kind of calculate those things if you really wanted to without this, but when you do a delay, you may not know, I may not know where the mouse X and mouse Y is. So now if I add a delay here, I can click. No, I didn't save it. Hold on. So I can click, move the mouse, and it will work out the calculations based upon the last position. And it's all calculated when the tween finishes its delay. Okay, that is a quick run through of some of the new things coming to TweenGMS, and currently in the beta. Again, you can download it from itch.io. I'll leave a link in the description. And also, if you want to check out GMLive, which allowed me to quickly live update these things without recompiling, I'll leave a link in the description to GMLive. It's definitely worth it. It's a bit of money, but it's worth it, guys. If you want to save some time, check out GMLive. For the next video, I would like to, again, place more time on these off-rails tweening. It allows you to override the default tweenfire, tweencreate, tweenplay functions to have like a more custom, like it just allows you to do cool things. And I look forward to showing you guys that in the next video, as well as being able to now use animation curves as ease types, which is great. Struct targets. So if you want a struct to be a target, you can now do that. It's a little sketchy with the current garbage collector. I recommend it only for more advanced users who know what they're doing. There's some caveats, but you can now use structs as targets. Oh yeah, I didn't show, well, some other cool stuff to show in the next video. Group timescales, so that in TweenGMS, you've already been able to assign groups to different tweens, which you can still do, but now you can set explicit timescales per group. So if you want to have different groups that have different timescales, you can now do that. So you can have per tween scales, per group scales, and global scale, which is cool. So anyways, I'd like to show that. And lastly, I may show you guys some general compiler optimizations for if you don't need, say for example, if you don't need group timescales, you can disable those, and at compile time, it will remove that feature, and TweenGMS will run faster because you don't need it, and so that kind of thing. Okay, guys, again, if you made it through this video, cool. I hope you found some of the features to be interesting. If I didn't explain anything clearly, if I've been mumbling the whole time, let me know. I'll try to make it more clear and maybe clear things up in the next video. I just wanted to give kind of a summary rundown of some of the more bigger changes. Some of the key features coming to the new version of TweenGMS, which I hope to add to the marketplace God willing, in the near future here. So anyhow, guys, let me know. Give me some feedback. Look forward to hearing from you. Blessings.